Hello, Chem242. I just wanted to put this quick little introduction together for the very first lab activity of this term. It's going to be all about spectroscopy. Really, the whole idea of this is just to kind of get you back acquainted with doing spectroscopy type problems. We're going to see some NMRs, we're going to see IRs, we're going to see something called a mass spec, which isn't going to be very important for this particular activity. And then, of course, I have put together this, pretty useful little handout. At least I think it's useful. What it's going to do is just kind of show you some of the tricks that the American Chemical Society exam kind of falls into asking about, and what I've tried to do in the various spectra that I have chosen is that hopefully you'll see some of the stuff that I talk about here. Keep in mind, right, that if you need to understand more about spectroscopy, I'd really go back to some of your work from last term that hopefully you have hanging around. And of course, the best way to learn spectroscopy if you're having problems is to talk to somebody that knows it. And I happen to know a guy. So hopefully this will be pretty helpful, but in terms of how to actually do the activity, it's going to be pretty straightforward. As always, you have a week to do this. When you click on the actual activity itself, what you'll see is these 4 different problems, right? And so here are all the different problems. And each one of these problems consists of 4 different types of spectroscopy. The IR, which we talked about, there's the mass spec, which for now we don't really care much about this, except for maybe just that it gives us a molecular formula to work with. The UV activity and such, pretty much that only tells you one thing, and I listed that out in your little introduction handout there. The one thing that I do want to talk about has to do with C13 NMR. We talked about what's called proton decoupled C13 NMR last term, and you see that is always listed off right here. The thing is that there are other types of NMRs that tell you other kinds of information, and some of them can be pretty useful. One of them is this thing called DEPT, and quite honestly, I can't remember what the acronym stands for, but really what happens is that anything that has an odd number of hydrogens is going to be in kind of an up peak here. So like these guys have odd numbers of hydrogens attached. Anything with an even number of hydrogens is going to be directed down. Anything with no hydrogens is just going to disappear. So you can kind of see how helpful this thing is in that we know automatically that that's some sort of CH2. These things are either CHs or CH3s. And then you got this guy that disappeared completely. So that's probably a carbon with no hydrogens. There is one other thing that you occasionally see. This is a little bit more rare, and that is what's called a proton coupled C13 NMR. And this will actually allow your C13 nucleus to kind of couple to the number of protons that it's directly bonded to. Usually you hit it with a pulse in the sequence that kind of gets rid of that because it can really make things messy. But sometimes in more simple spectra like this, you can see that it might actually be pretty helpful. If you remember that n+1 splitting rule, right? That, for instance, here, this peak right here, the fact that it becomes 4 peaks, otherwise known as a quartet, that because this follows n+1 splitting, we know that that guy is a CH3. This guy right here, CH, because he's split into a doublet. So you get the idea. If you have questions about that, please let me know. Probably the most useful of any of them is probably the depth spectra. As I said, I tried to pick out a couple of like really endemic type of problems here that show like some really common things that we're going to need to learn to recognize pretty quick. So if you have any questions, you guys got a week. Talk to me in those Zoom office hours.